Hi, this is Kevin from Let Me Tech You. In this video, I want to talk about a network design in Azure that can be utilized to kind of help do one of three things and possibly other Azure best practice. Put you in the best position to have best practices in Azure when you're building large networks. And I want to bring this diagram up here. So basically, when you're working with a large network in Azure, couple things you might run into is one is IP exhaustion, and that can come from improper planning. Networks becoming too large. As you grow. So, and with that, this design can kind of help mitigate some of that, and it also can be utilized if you aren't in the position of running out of IP addresses. It could be something that you could set up to separate services from being directly access from the internet, improve security by funneling or tunneling all your traffic through a central hub. And with that, we're going to have this design. And basically, just to kind of go over how this is, your typical hub and spoke network that's designed in Azure to basically facilitate all your network traffic going through one hub network. And if we look at this picture here, this is a recommended architecture from Azure. There's two ways that they kind of go about looking at ways to prevent IP address exhaustion. One's with this particular setup using a Azure SNAT device, which is whether it be a network virtual appliance or an Azure firewall to route traffic through that, or you could use Azure Private Link services. But in this one, we're going to talk about how in the spokes here we have a Azure firewall that will take this non-routable spoke. And when we say non-routable, we mean non-routable in the sense that it's not routable to other portions of the network directly, being that peerings aren't transitive by design in Azure. So you need some type of appliance to be able to tell the traffic where to go. So we're going to have some route tables in the subnets here that's directing traffic to this Azure firewall. And then any and all traffic will then be going to the main hub, which will then go out to the internet. Same vice versa. And then we'll go through another video at some time talking about how we could possibly, then do some transitive routing by, facilitating the routes here to send traffic from one spoke to the other. Or you can do things like direct peering if these two are to be talked together but don't need to go through the all these extra hops. So, with that being said, I wanted to talk about this and actually show it being done in Terraform, because one thing that this can help with is that you can set this up as a lab. If you want to follow along, there's a GitHub link down below, and the Terraform for this is pretty decently large, not that big. As you can see here, I've been putting this together, so I'm going to kind of go through this here. So I have my resource groups, which I have my hub, landing zone 1, landing zone 2. And then inside of those, I'm going to have my virtual networks. So I got a virtual network for the hub. I'm going to have a VM subnet and an Azure Firewall subnet in the hub. Now, the VM subnet's basically just going to be so that I can look at my effective routes, based off the peers that are connected. A landing zone 1 and then landing zone 2. Each landing zone will consist of one resource group that will hold both the routable and non-routable VNets. And so then inside of this VNet here, we're going to have an Azure Firewall subnet with a route table to that firewall that pushes any and all traffic from the non-routable spoke here to the main hub. Same thing, just duplicated here. And the great thing about doing this in Terraform is we can replicate this and make it easier to deploy over and over again. So when we get the networking set up, I got some VMs here, and I'll put, like I said, I like to kind of separate these out in different .tf files, so that way I can kind of see what's all going on. So I got my VMs here, I have my peerings, my network security group. So it's best practice to add a network security group to any and all subnets. That way you can do some things like NSG flow logs it's just good practice to have a default NSG applied to any subnet that it can. And so then also I have this RDP access set, and this is only for me to be able to get to it here while I'm at, I'm testing. So obviously you wouldn't want to have RDP access allowed to the outside world. You'll probably want to put in like a source address prefix of your home location or business location. Then I got a bastion set up here. So basically, if I look back in here, we got these two non-routable spokes. And I'm going to have, and I may not need this, but I wanted to kind of show it. What I can do is, instead of using the Azure Bastion, these VM subnets are going to be routing traffic directly to the Azure Firewall here and then out through the internet using this main one in the hub. So I didn't want to put a public IP directly on the VMs in that subnet. So that way we can show, once I RDP to it from the Bastion, that it's going to actually be getting its outside IP address from the firewall in the main hub. So just going based off these little tidbits up above, prevent IP exhaustion. So with this design, you could actually essentially use the same IP address inside of each spoke up here and then still be able to get out through the internet or to any other parts of the network, as long as you're, because what's going to happen is you're going to be source snatting the traffic coming from this particular subnet using the Azure Firewall's private IP address here. So the hub firewall is going to see traffic coming from the 192.168.2.0 address and not the 192.168.4.0. So that's how you can save on IP addresses, because if you ever run into the point where you're running low or having to reuse IP addresses, your SNAT devices in the routable spokes will be what the hub will be seeing. So now we got our Azure Firewall in the main hub, and that's going to actually just going to be what's going to direct traffic out. So I'm going to go ahead and deploy this here. And again, this is basically just some very small VMs with NSGs and subnets and peerings and route tables being defined. So I'm going to run this. It's going to take a while. It's going to take a while to deploy. And so it's going to take a while. So I'm going to pause this and I'll come back and let's see, we got an error here. Oh, so I think I had some stuff already existing that I might need to get rid of. Let me see here. All resources. So I've been running a couple of different tests here. So let's see, we got some resource groups. Okay, so we just got some resource groups that need to get deleted. So let me go Wing Zone 1. Just delete that resource group. So I'll get these deleted, I'll get that deployed, and then we'll go from there. Okay, so that's finally deployed. So we got as you can see, 76 resources added. So now let's go into the portal here and just go ahead and go to all the resources that deployed. Now, looking at this diagram here, so basically we got our hub, resource group, VNet, subnets, and the VM deployed with an Azure Firewall, 2 spokes that are direct peers to the hub, and then 2 non-routable spokes with direct peering to the routable spoke that don't have transit or routing from the other hubs. So what I'm going to do is we're going to jump on this. I got 2 VMs in this spoke, non-routable spoke 2 here. One actually has, like I said, a public IP on it, really just using it as like a bastion host. And what I'm going to do is I'm going to log into the VM here, and I'm going to try to do some tests. I'm going to try to get to the other side, to one of the other VMs. And I'm also going to show you how this is going to actually work as far as it showing itself going out the hub Azure Firewall. Now, again, that could be a Palo or Cisco firewall, whatever your network virtual appliance of choice is. So to kind of walk through that here, I go to my resource groups. So I got my landing zone 1, landing zone 2, and my hub. So I'm going to go inside landing zone 2. And I got my non-routable VNet and the routable VNet. So inside this VNet, under connected devices, I have my Bastion VM and then the VM that just basically is used to do our testing. So if I go to this NIC, should be a public IP address on there. I'm going to copy that. And I should have already had that set up in my remote desktop of choice. I'm going to go ahead and log into that. Now that password and username is in the Terraform file, so you can copy that password and username from there and paste that in, or whatever you set for it. So now this logs me in here. I'm going to go ahead and then log into one of the other VMs. Now I'm going to go ahead and grab the IP address of that. So if I switch back to the portal, go back to connected devices, for that VNet, I see that it's 4.4. And you can actually click on the VM, and we have so for those particular subnets, we have route tables created. And so for this VM subnet, we have a route table associated with it that's sending all traffic to the next hop of a virtual appliance, which is the Azure Firewall's virtual private IP address. So there's 192.168.3.8. That's coming from this Azure Firewall here, private IP address there. And so then on here we have an Azure Firewall policy that just says allow any traffic out. And now you can skinny this down to make it more granular, whether it be a specific source, subnet, or range, or whatever. But this is basically just sending everything. Now, to get it to the destination of the hub, public or Azure Firewall, on this VNet in the routable spoke, there's a route table associated with the Azure Firewall subnet, which has its next hop as the private IP address of the hub Azure Firewall. And then on there's an actual, and if we keep following down that train, go into the hub firewall private IP is 5.68. And so then this Azure Firewall has a policy associated with it that basically just says allow anything outbound. So now if we go back into also note for that Azure Firewall in the hub, the private IP or the public IP address is 172.173.83.102. And when we jump on our VM in the other non-routable spoke, we should see that it's not actually going to be able to, it's going to actually show that as its outside IP address. And we can actually start to see if we do see any traffic going through the Azure Firewall by going into the firewall's metrics and looking at the throughput. And as you can see, we got some throughput here. It's not going to be much when we're dealing with just some test VMs, but you can see the difference in utilization as we got those VMs spun up. And so now let's go ahead and log in here using your remote desktop session of choice. Now I'm going to, so I already had that in there. So let's go ahead and paste my password. And so now that this is logging in, this doesn't have a public IP associated with its NIC. But when I go into the internet here, we're going to see that it's coming up. And we're going to go to google.com. And we're just going to type in, what is my IP? And as you can see, it's 172.173.83.102. Try to hit some other sites just to generate some traffic. ESPN.com. Just to get some traffic flowing through that there. So now with our segmented service, if we can go back to our drawing here, basically if we take the path here, or here, it's going through here, hitting the Azure Firewall. The Azure Firewall is then natting or source natting the traffic using this subnet for the Azure Firewall subnet and pointing it to the hub. So the hub then sends it out via its public IP address. Now, this here isn't transitive unless you have some way of saying, hey, if I want to get to this particular subnet, I need to add some particular rules here to direct that traffic to this particular Azure Firewall. But we won't. We'll dive into that in another video. But I'm going to just show you that this won't work here when I try to ping 3.4. Now, I believe that's the IP address, but we can check that out here now. So we go to the non-routable VNet, go to connected devices, and we got 2.4 here. I believe that's what I had. Let's see. 1, 2, 2.20. Might have just had. Let me check and see. So 1, 2, 3, 4. So what's using 3? So if we look in the, so that's using 4 and that non-routable, and then so I might have just had the okay, 3's being used in LZ2. So that's fine. So we at least know, so this is 3. I'll adjust the drawing here before I upload it. So let's actually do that now here. So this is going to be 3. And this is going to be 2.0. So if I go back onto my VM, and we can actually walk that down. So let's do a ping across the peers here, and let's see how far we get before we can't ping anything else anymore. Moving a little slow. Now these are just small instances, so the resource utilization might be a little slow. So if I do a ping 192.168.3.1, well, that's actually going to probably be the let me let that time out. It's going to be 3.68. So we can get to 3.68. And then, so let's try and even get to 5.68, which I believe that's what that was. If we go into the route table, well, let's just go to the hub. So 5.68. So can we get to that from that non-routable? No. So basically, this doesn't have a route, or no, it doesn't have a way to basically get the traffic back from that Azure Firewall back to the non-routable. So if I was actually in the, pull this up here, if I was in this particular VNet or VNet, I would be able to get directly to it, because again, this traffic is non-transitive, unless it's being snatted out the Azure Firewall here. So, and again, also, so now if you wanted to improve security with like separate services outside of just, wanting to do some preventative IP exhaustion, This is one way to kind of do that. So you could essentially have your services tiered in a sense that this could be a web tier. You could have your app and or databases back here that don't need direct access to the internet, or however you're configuring that. You could have these spokes could be zones that don't need internet access, but they do need to talk to each other. It could be, replicated databases or some type of jump boxes. So you could have jump boxes here that could essentially allow you to, manage your resources here without having to give it direct internet access. So you can essentially do a peer directly. So you would basically have this arrow, without even having to draw it, which just this probably doesn't turn very well within, no. So we're just gonna just pretend. So there's gonna be a line that goes behind there and to these two. Actually, we can just flip this here. See if we can get this turned. Yeah, my drawing skills isn't the best on this. So basically, there would be a connection there. And another good thing about that is you won't have multiple hops. So if you did want to try to get to this network and you didn't need to actually have this going through a firewall to, look at, source and destination traffic, you could, go ahead and peer these two together and just not allow any forwarded traffic to be accessed to it. So essentially, you can have something in this spoke try and get to this network by going through that, peering connection. And you can have your NSG flow logs on there to have your NSGs sent to a logging device or a event hub or storage account of your choice. So again, as we go through and look at this particular design, great way to prevent IP exhaustion using Azure's recommended approach of separating your spokes by a network virtual appliance and having it source NAT all your traffic to a hub device. Again, there's probably other scenarios you can probably build out of this. Again, the Terraform that I deployed is a great tool to use because I usually use this to do some testing and things with that, and you wouldn't want to really have to go through and build out every single portion of this network hand by hand, as you're building it out and possibly forget something. So go ahead, you can check out my GitHub down below, and if you have any recommendations or questions around how it's designed or ways to add some things that you're utilizing to it, shoot me a comment down below and I'll be sure to get back with you. And if you're only doing this for testing, always make sure, a good thing why you should do this in Terraform is you can easily destroy this entire environment. So when I'm done, do a Terraform destroy. And it's going to run through all the different resources that we built out. And so we're going to destroy 76 items here. So we're going to hit a yes for that. And so now basically you can utilize this to, test out different scenarios and, build it back up within minutes without having to rememorize everything that you've done over and over again. So I'll get this to pushed up here. Let me actually do this now. So terminal. So I'm going to, and for the VMs here, these passwords I added in here, just some generic passwords. I'll comment them out, but you'll need to make sure you add passwords to your VMs that you'll want to have deployed. So that way we don't have to check these into source control here. Comment that out. Let's comment this out. Save that, and let's go ahead and, so this is the firewall policy. Let's go ahead and add that. to the changes. The Bastion host, add that. The Azure Firewall. The NSG, that's for the RDP. You don't need that particular section, but I'll keep it in there. But just remember, you don't want to have this allow any in a production. I would kind of utilize this more for testing. Then our peerings, you want your peerings between all the different spokes, the different route tables here, and then the VMs that go inside each VNet. So now if I go through and let's do a git commit. All right, so that's in my Terraform repository. So if you want to get to that, you can just go to github.com/let me tech you. And I have a Terraform v2 folder. And as you can see, just uploaded that now here. Okay. So yeah, again, if you have any questions, shoot me a comment down below. Be sure to get back with you. Again, hopefully, if you had any questions around how this was set up, or you came across Microsoft article on preventing IP exhaustion, that this can help you do that within Terraform versus having to do it manually. Again, thanks for tuning in and hope to see you next time.